there is a one type of integration which makes the student happy. The student always happy with this type because it is quite easy. The two functions are given and e raised to x is written outside the bracket, and the result is also quite easy. And it generally appears for 1 or 2 marks in the examination, and student easily scores this 1 or 2 marks. So this type is very easy, but I request you that do the problems along with me for better understanding. So can you guess what is that type? 1 minute, hold on. I will tell you what is that type. What is the type? Can you guess? Guess. The type is integration of e raised to x into f of x plus f dash x with respect to x. This is equals to e raised to x into f of x plus c. So today I am going to solve the problems of this type. I am going to solve some 5 to 10 problems of this type. So please be ready with your pen and paper so that you can do the problems along with me. So let's start today's episode. That is the integration of e raised to x into f of x plus f dash x with respect to x is equals to e raised to x into f of x plus c. The example number 1, integration of e raised to x and inside the bracket root x plus 1 upon 2 root x with respect to x. So let f of x equals to root x, and we know that the derivative of root x is nothing but 1 upon 2 root x. Therefore, let f of x equals to root x, whose derivative is nothing but 1 upon 2 root x. And what is the formula saying? E raised to x, f of x, f dash x equals to e raised to x, f of x. Therefore, integration of e raised to x root x plus 1 upon 2 root x with respect to x. Here root x nothing but f of x and 1 upon 2 root x nothing but f dash x. And what is the result? Result is e raised to x f of x. So e raised to x, what is f of x? F of x is the root x plus c. So can be written properly, root x into e raised to x plus c is the solution. So answer of this question nothing but root x into e raised to x plus c. This is the answer. One more example. Example 2, evaluate integration of e raised to x into sin inverse x plus 1 upon under root of 1 minus x square with respect to x. To do this type of problems, your derivatives must be strong enough, and if your derivative is not strong enough, then please visit the playlist. You will find ample of problems, solved problems based upon the derivatives. Now let us proceed. Here let f of x equals to sin inverse x, then derivative of sin inverse x nothing but 1 upon under root of 1 minus x square. Therefore, integration of e raised to x sin inverse x plus 1 upon under root of 1 minus x square with respect to x is nothing but e raised to x, that is e raised to x into f of x. F of x nothing but sin inverse x plus c. So this is required solution. Let us do one more example. Example 3, evaluate integration of e raised to x into log x plus 1 upon x with respect to x. We know that derivative of log x is nothing but 1 upon x. So let f of x equals to log x, then f dash x equals to derivative of log x nothing but 1 upon x. Therefore integration of e raised to x log x plus 1 upon x with respect to x. What is the formula? Formula is nothing but e raised to x outside the bracket, and here is log x, that is f of x, and 1 upon x nothing but f dash x. What is the result? Result is e raised to x into f of x. So that is nothing but e raised to x. What is f of x? F of x is the log x. Therefore, integration of e raised to x into log x plus 1 upon x with respect to x is equals to e raised to x, and f of x is nothing but log x plus c. So this is required solution. Example 4. Evaluate integration of e raised to x 1 minus cot x plus cot square x with respect to x. This type of problems sometimes require simplification before start doing integration. So here e raised to x as it is, and here 1 plus cot square x can be written and minus cot x with respect to x. Now 1 plus cot x square x is nothing but cosec square x. So in place of 1 plus cot square x, you can write cosec square x minus cot x with respect to x. Now you have to decide what is f of x and f dash x. Cot x nothing but f of x, and derivative of cot x is nothing but cosec square x. So this becomes f dash x. So let f of x equals to minus cot x, derivative of minus cot x nothing but minus cosec square x. So that is equals to plus cosec square x, implies integration of e raised to x cosec square x minus cot x with respect to x is nothing but e raised to x into f of x. That is nothing but e raised to x. What is the f of x? Minus cot x. So this is equals to minus e raised to x cot x plus c is required solution. So minus e raised to x into cot x plus c is required solution. Let us move to next example. Example 5. Evaluate integration of e raised to x and inside the bracket 1 minus x square sin inverse x plus 1 upon under root of 1 minus x square with respect to x. Again we require simplification before doing integration. So what is that? Here splitting upon under root of 1 minus x square plus 1 upon under root of 1 minus x square with respect to x. So you might be knowing that a plus b upon c, that is equals to a upon c plus b upon c. So I applied just that formula. So under root of 1 minus x square will cut down. We get here e raised to x into sin inverse x plus 1 upon under root of 1 minus x square with respect to x, integration. Now let f of x equals to sin inverse x, and we know that derivative of sin inverse x is 1 upon under root of 1 minus x square. Therefore, integration of e raised to x sin inverse x plus 1 upon under root of 1 minus x square with respect to x is nothing but e raised to x into f of x. What is f of x? That is sin inverse x. So what is the final answer? Final answer is integration of e raised to x sin inverse x plus 1 upon under root of 1 minus x square with respect to x equals to e raised to x sin inverse x plus c. This is required solution. You see, whenever you are doing integration, nobody can teach you integration because it is totally logic. Every type problem is different. Every time you will get the different problems. So you require your own natural talent to solve the problems. Only the teacher can show you some solved example. I can solve some problem for you. From this you can gain the experience how to handle the different situations. But actually whenever the problem is given, you need to have your own brain. You need to have your own experience. For example, in this question, there is no f of x and there is no f dash x. Now how to do this example? So we require some logic here. The logic is that to create f of x and f dash x, we require to add here +1 and -1 upon x plus 5 whole square with respect to x. So this is equals to e raised to x. Here is the x plus 5 minus 1 upon x plus 5 whole square with respect to x. So this is equals to e raised to x, x plus 5. Now splitting into fractions, x plus 5 upon x plus 5 whole square minus 1 upon x plus 5 whole square. So with respect to x, you see that if I am not knowing this all idea, then I won't be able to solve this problem. Whatever you do, you will not get the solution unless and until you apply this logic. So you got an idea now that whenever the f of x plus f dash x is not there, but in the numerator one number is smaller than denominator. Here is a x plus 4, here is x plus 5. That implies there is required to add 1 in the numerator. When you add 1 in the numerator, after splitting you will get the two parts. That one part becomes f of x and the second part becomes f dash x. Here is the x plus 5 upon x plus 5 whole square is there. So this and this can be cut down. After cutting, what do you get here? E raised to x, and here 1 upon x plus 5 minus 1 upon x plus 5 whole square, and with respect to x. You see f of x, let f of x equals to 1 upon x plus 5. As soon as the problem is given, you require the talent to identify f of x and f dash x. This is possible only when your derivatives are strong enough. And to make your derivative strong, don't bother not to go anywhere else. Just visit my channel and you will find lot of problems, solved problems based upon the derivatives. And so f of x is equal to 1 upon x plus 5 and f dash x is nothing but minus 1 upon x plus 5 whole square. Therefore what? Therefore integration of e raised to x 1 upon x plus 5 minus 1 upon x plus 5 whole square with respect to x equals to e raised to x into f of x. What is f of x? What is f of x? That is 1 upon x plus 5. So what is the final answer? The final answer of this is nothing but e raised to x upon x plus 5 plus c. This is the final answer. Example 7. Evaluate integration of 1 upon log x minus 1 upon log x whole square with respect to x. Here there is no e raised to x outside. Then how to create the e raised to x? For that we go for substitution method, that let log x to the base e equals to t. If base is not given, then base e always present. If your logarithm is not strong enough, then please visit my channel. You will find lot of solved problem based upon the logarithms. So here we put log x to the base equals to t. So what you do now? Here imply this is the logarithmic form. Now convert into index form, implies e raised to t equals to x. Call it 1 and call it 2. Now therefore one more thing we'll do, that I equals to, here we multiply and divide by x. This is the logic, because you have to create the e raised to x outside the bracket with respect to x. So whenever we go for substitution method, we do derivative. So derivative of log x to the base e with respect to x equals to dt by dx. After that, what will you do? So derivative of this nothing but 1 upon x equals to dt by dx. Therefore 1 upon x dx equals to dt. So this method of integration called substitution method. And after that, here this, let us call it as a 3, call it as 4. Now from 2, 3, 4. From 2, 3, 4. Now expression 3 will become, here 1 upon x dx will go away, and in that place dt will come, and here is a 1 upon log x, 1 upon log x, that is nothing but 1 upon t, and 1 upon log x whole square, that is nothing but 1 upon t square, and in place of x, what is x? X nothing but e raised to t. So here was the x, so in place of x write down e raised to t. Now we got this form, that is the integration of e raised to x into f of e raised to x into f of x plus f dash x with respect to x equals to e raised to x into f of x plus c. So this becomes e raised to t. We know that derivative of 1 upon t with respect to t is nothing but minus 1 upon t square. Therefore f of t equals to 1 upon t and f dash t equals to minus 1 upon t square. Therefore integration of this is nothing but e raised to t into f of t, that is equals to e raised to t, f of t nothing but 1 upon t. So e raised to t upon t plus c. But this is not final answer because the question is given in terms of x. So we have to do the back substitution here. Now e raised to t nothing but e raised to t nothing but x. So in place of e raised to t write down x, and in place of t you see here is the x and here is the log x, that is a log x to the base e plus c. This is final answer. Here is the example 8. Evaluate integration of e raised to x 1 minus sin x upon 1 minus cos x with respect to x. Before start using this formula, we need to create f of x and f dash x. That means we need to simplify the bracket. So integration of e raised to x 1 minus sin x can be written as 2 sin x by 2 dot cos x by 2 upon 1 minus, here cos x can be written as 1 minus 2 sin square x by 2 with respect to x. Now opening the bracket in denominator, so we get 2 sin square x by 2 with respect to x. Now splitting 1 upon 2 sin square x by 2 minus 2 sin x by 2 dot cos x by 2 upon 2 sin x by 2 sin square x by 2 bracket close with respect to x. This is equals to e raised to x. Here 2 get cancelled, sin x by 2 get cancelled. We do get here 1 by 2 cosec square x by 2 minus cot x by 2 with respect to x. So we got the two terms in the bracket. One becomes f of x and the second becomes f dash x. So we know that derivative of cot is nothing but cosec square. Therefore let f of x equals to minus cot of x by 2 f dash x nothing but 1 by 2 minus is there and minus cosec square x by 2. So that is equals to cosec square x by 2 upon 2. Therefore I equals to, I means the result of integration, I equals to e raised to x. Here e raised to x, and here is nothing but minus cot x by 2 plus 1 by 2 cosec square x by 2 with respect to x. This becomes f of x and this becomes f dash x. The result is e raised to x into f of x. That is the result of integration. That is e raised to x. What is the f of x? Nothing but minus cot x by 2 plus c. So this can be written as minus e raised to x cot x by 2 plus c is a required solution. Next question. Evaluate integration of sine of log x plus cos of log x with respect to x. Here also e raised to x is not there. Whenever the two functions are there and both the functions are the function of log x, then in general we multiply and divide by x here like this, dividing and multiplying by x, then sine of log x plus cos of log x with respect to x. Then let log x equals to t implies e raised to t equals to x. Call it 1, call it 2. After that, when we are putting log x equals to t, we are undergoing substitution method. So differentiating with respect to x. So differentiation of log x with respect to x equals to dt by dx 1 upon x dx equals to dt. Now in given question 1 upon x dx, that can be equal to dt. Therefore I equals to integration of, in place of this x I can write e raised to t. So e raised to t and 1 upon x dx, that is equals to dt. So write here dt and inside the bracket sine of log x is nothing but t. So sine t plus cos t. Now this can be considered as f of t. Then derivative of f of t is nothing but cos t. So integration of e raised to t f of t plus f dash t equals to, with respect to t, equals to e raised to t into f of t. Therefore integration of e raised to t sin t plus cos t with respect to t equals to e raised to t. What is f of t? Sin t. Now we have to put back the values. So what is t? T nothing but e raised to t nothing but x. Therefore x will come here, and sin and t nothing but log x. So sine of log x plus c. This is required answer. Therefore integration of sine of log x plus cos of log x with respect to x is equals to x into sine of log x plus c. This is required solution. This is the last example. Evaluate integration of e raised to x 1 plus x square upon 1 plus x whole square with respect to x. Solution. We required some simplification here, adding and subtracting 1 here upon 1 plus x whole square with respect to x. So e raised to x 2 plus x square minus 1 upon 1 plus x whole square with respect to x. e raised to x to, taking minus common, 1 minus x square upon 1 plus x whole square with respect to x. Now this is equals to, you see, we cannot teach you integration. We can just solve and make you understand some examples. But whenever the new problem is coming, it is very important that you should have your own logics. You should have your own talent, because there are the hundreds of problems and hundreds of ideas. Whenever a teacher solving in the classroom, he can solve 10, 20, 30 examples, but the 31st example will be different, for which you required your talent to be utilized. So that can come with only with practice. So start practicing questions from your textbook, start solving them. If you have any difficulty, you are not able to get the solution, please refer the question to me. I will solve them and help you. Now here e raised to x is outside, and 2 and 1 minus x square can be written as 1 plus x into 1 minus x divided by 1 plus x whole square with respect to x. Now splitting into fraction, e raised to x 2 upon 1 plus x whole square minus 1 plus x into 1 minus x upon 1 plus x into 1 plus x, because square is there, so I have written twice. Now this and this cut down, so what is left? E raised to x and 2 upon 1 plus x whole square minus 1 minus x upon 1 plus x with respect to x. So after this, we have to decide what is f of x and what is f dash x. You see, we can guess that 1 minus x upon 1 plus x can become f of x along with the minus sign. And here is denominator 1 plus x square, 1 plus x whole square is there. That means certainly this is the result of quotient rule of derivative will provide 2 upon 1 plus x square. So the blind guess is that f of x equals to minus, and here is a 1 minus x upon 1 plus x. Now we'll find out f dash x and see whether our guess is true or false. So f dash x, I am writing f dash x directly, but you calculate yourself. So we got f dash x equals to 2 upon 1 plus x whole square. So our trial was correct, that this much part is f of x and this much part f dash x. Therefore, integration of e raised to x into 1 plus x square upon 1 plus x whole square with respect to x equals to e raised to x into minus of 1 minus x upon 1 plus x. This is equals to e raised to x into x minus 1 upon x plus 1 plus 3. This is required solution. So after solving these 10 questions, you might have got a little idea that how to deal with such problems. There are the many more problems are left due to the time constraints. I am not able to solve all the questions here. But I request you that start solving questions from your textbook. If you feel difficulty, if you face difficulties, then please contact me on my email address. Provide me your details, so I will contact you and I will solve your difficulties. I will help you to solve your difficulties. This is my promise. Meet you again with another topic. Till then, wish you good luck. And before saying goodbye to you, I would like to request you like, share and subscribe the channel so that you will be always getting the latest videos on many of the mathematics topics like the integration, like derivatives, like trigonometry, like differential equations and many other topics. So let's say goodbye. Meet you again with another topic. Till then, wish you good luck. All the best.